All right, so this is video 2 for Cramer's rule. All right, so Cramer is spelled kind of weird. Yeah, Cramer's rule, and it's basically this algorithm for solving a system of equations using determinants. So we had mentioned, for determinant they have this little shorthand notation, the little bars. So if you had, actually, let me just fill it in with our numbers. We have 2, -5, 3, and 4. And so the determinant is this 2 times 4, which is 8, and then minus 3 times -5, which is -15. So this comes out to be 8 plus 15, or 23. Okay, so the little bars, that represents determinant. So in our formulas that we found last time, we noticed that the bottom is the same here, AD minus BC, and that's going to be the determinant of our original matrix. All right, so I can actually go ahead and substitute that in. The AD minus BC was that 23 I just found. Okay, and then for Y, same idea. Still the 23 here. So for these numbers, it's kind of confusing the way that they're read, but I'm going to show you where or how Cramer's rule is actually spelled out. But first, let's go ahead and label this. It was A, B, C, D, and then this was E, and that was F. So to solve for X, we would be doing D times E, so that'd be 4 times 15. So I guess that's 60. And then minus B times F. All right, -5 times 12, which is -60 again. All right, so we get 120 up top and 23 down below. Now, I guess you'd want to check and see if this will simplify, but 23 is prime, and I don't think it goes into 120. All right, and then for Y, we would do A times F, so 2 times 12, that's 24, and then minus C times E. All right, 3 times 15, that's 45. Ooh, 24 minus 45, that's negative, feels like 21. We're going to go with that. All right, so these are our two solutions. Let me see what these are as a decimal real quick, just to make sure we did this right. All right, 120 divided by 23, 5.2, 217, put that. And then for the Y value, -21 divided by 23. All right, -0.913. Now, to check this out, what I'm going to do is I'm going to graph these. Yeah, using our calculator. This was one of our many methods for solving these. What I did was I went ahead and converted them into slope-intercept form, moving the 2x over, divided by -5. And I've got them both entered in here, y1, y2. Zoom standard, we'll graph it. And we're just looking for where they cross. We're going to go to our calc menu, second calc, intersection. And then for lines, you don't have to really do anything. First curve, it's this one. Enter. Second curve, it's that one. Enter. And guess. You want to get close to where they intersect. There we go. We got 5.217 and -0.913. Woohoo! It works. See, the thing is, though, this right here, you're not going to remember this formula. It's crazy hard. So what they do is they give this weird notation here. It's going to be the determinant of x, or determinant in x, divided by the actual determinant, which is like that 23. And then for the y value, it's the same idea. Determinant dy, I guess, divided by d. So how these numbers arise, let me see here. So our matrix was 2, -5, 3, and 4. And I guess I'm going to write, I don't know if this is official, 15 and 12. So to find the determinant of x, that dx part, the way you do this is you take your answer part, the right side of the equation, and you substitute that in for the x column. 2 and 3 represent x. So we're going to do this determinant, this dx. We're at the little bars this time. But I'm going to replace the 2 with the 15 and the 3 with the 12. Okay? But the y values are just going to stay normal. And then you actually find the determinant of this matrix. All right, that's going to be 15 times 4, which is 60, minus, and then 12 times negative 5, which is negative 60. So that's how we get 120, which is what we had here. So they call that the determinant in x. All right, for the determinant in y, dy, you do the same idea. You're going to take your answer matrix here, I guess your answer column, and substitute that in on the y column. So 2 and 3, those stay put, but the 15 goes where the y's did, and the 12 goes where the other y did. All right, and then you just calculate the little basic determinant, AD, which is 24, minus 3 times 15, that's 45. Subtract those and you'll get negative 21. And that's where that number came from. Okay, let's do one more example. Let's see where I had it here. Oh, I have it written down. There it is. Okay. So instead of memorizing this thing, which is cool, I guess, if you're into memorizing lots of stuff, you memorize less. All right, this is Cramer's rule, and we're going to use it to solve this thing. So we're going to have to find the determinant of 3 separate matrices. Let's do regular D first. All right, that one. So regular D, our matrix is a 1, negative 1, 2, and 1. Okay. The determinant here, 1 times 1 is 1, minus negative 2. So we get 3 for D. There it is. Okay, D is equal to 3. Now for dx, or d sub x, whatever you want to call it, you're going to replace these coefficients, the 1 and the 2, with your right side column, I guess, your answer column. So it's going to be a 4, 2, and then the y values, these stay put. So negative 1 and 1. All right. Determinant is going to be 4 times 1, 4, minus 2 times negative 1. So you get positive 6. All right. So we already know what x is equal to. X is equal to dx divided by d. So that's going to be 6 divided by 3. That was our d. So x is going to equal 2. We got that one figured out. For dy, of course you can do some of this in your head once you get familiar with it. Dy, you're going to keep the x columns the same, 1 and 2, but you're going to replace these y values with your right side equation, or the right side of the equation, 4 and 2. 4 and 2. All right, determinant is 1 times 2 minus 2 times 4, that's 8. So you get negative 6. Dy divided by d, so it's y equals dy, which is negative 6, divided by d. That's negative 2. All right, and that's it. If you wanted to check your answer, I suppose you could take that 2 and plug it in for x, and take this negative 2, plug it in for y. Make sure it works on both equations. Yay, good job.